Hi guys, in this video I am going to explain about types of numbers. As you can see that we're going to use a lot of numbers, of course, in mathematics, so that's why we need to learn about types of numbers. And the first type of number that we're going to learn is about natural number. So basically, natural number is a number which are naturally used for counting. Remember when you are in elementary school, when you the first time you are counting numbers, right? You will start from 1 and 1, 2, 3, 4, 5, 6, 7, and so on, so on. So all of those numbers are what we call the natural numbers. So it's the same thing like counting numbers. You use your finger. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to infinity. This is what we call natural numbers, and it is denoted by the capital of N. So if I write down here, it's denoted by capital N. Here we go. So if you see capital N in mathematics, maybe when it says something like this, maybe later on you will learn about algebra, right? It means that the value of this thing here is going to be a natural number. Okay, let's go to the next one. The next one is a whole number. It's actually it's part. A whole number is actually a number in which all of natural number is actually a whole number, but you add it with 0. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, right? So before, previously, in natural number, it starts from 1, 1, 2, 3, 4, but whole number starts from 0. So 0 is the addition of natural. If you add natural number with 0, then you will get a whole number. Okay, and then we have the next one is integers, and integers is actually it's actually just like adding the natural number and then the whole number, but this time you add it with 0. So previously you're starting with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you added 0, right? So these are natural number, right? It's natural number, and then if you add it with 0, you will get a whole number. But if you add it with negative numbers on the left side of the number line, right, so you'll get an integers. Okay, so in here, if you see these 3 dots here and this one here, it means that it goes infinity. So if you go right, it means that it's going to be going to positive infinity. If you go left, you will get to negative infinity. So this is what we call integers. So it's the same thing like counting numbers and add 0, but you have negative numbers also, like negative 1, negative 2, and so on. Okay, the next one is what we call a rational number. So rational number is any number that can be expressed as a ratio of 2 integers. Okay, so maybe you are not too familiar with this word here, ratio. So ratio is actually if you compare two numbers, right, two values, like in division or in fraction, right? So if I write it down ratio, I can write it down as like P over Q. I mean, like this is a number and this is a number, right? So for example, like this, we have 1 over 2. 1 over 2 is a rational number. Why is it a rational number? Because 1 is an integers and then 2 is also an integer. So when you see a fraction like this, 1 over 2, if you see on the top and on the bottom here, we have this, we call it the numerator, right? And then this guy here, we call it denominator, right? So the numerator and the denominator should be a whole number, integers. If both of them are integers, then we can say that this is a rational number. Another example, we have 2 over 3 here, 2 over 3, and then 2, and then compare by 3. It's the same thing like ratio, 2 over 3. So because this is an integers and this is an integers, so we can say that it is a rational number. It's the same thing like this one here. So the difference is that we have a negative sign in front. So actually it's the same thing. If I put the negative, let's say on a 5, so it's like negative 5 over 7, we know that negative 5 is also an integers and 7 is integers also. So which means because both of them are integers, so we can say this fraction is a rational number, and so on and so on. So another question, guys. So what do you think of this number here? Is this a rational number? So because previously I said that the rational number is actually a ratio of the integers, like it's like a fraction, right? You have like p over q, right? So a number divided by another number, right? Then you get a rational number. So how about this guy over here? What do you think? Okay, so if you think that this is not a rational number, so you are incorrect. Okay, so actually this is a rational number. We can write this down, actually, guys. We can convert this. If I want to write it down as a ratio, I can write it down 3 over 1. Okay, so 3 over 1 is equal to 3, right? So because we can write this down as a ratio or as a fraction. So we can say, oh, this guy is a rational, this guy is also rational, right? 3 over 1 is equal to 3. It's the same thing. So you can simplify things, right? Simplify numbers. So because 3 over 1 at 3 can be written as 3 over 1. So and 3 and 1, which is the numerator and denominator, both of them are an integer, so we can say 3 is a rational number. So be very careful, okay, guys. Okay, let's get to the next one. Here we have rational and we have irrational. Okay, so actually rational and irrational is like the opposite. So if you see that like this one here, we have a rational number, right? We can write it down as a fraction. So basically, actually, if you want to convert this into a decimal, is the same thing. If I write down, so okay, so I'm gonna give you another example, guys. So if I have, let's say, 0.3, question is this a rational number? So what you need to do to determine whether it is a rational number or not, you need to convert this into a fraction first. Okay, so if I have 0.3 is the same thing as 3 over 10, correct? Because we know that the numerator, this one here, is 3, which is integers, and 10 as the denominator is also an integer, so we can say 0.3 is also a rational number. Okay, so what if you see like this, 0.66666, and so on, right? So is this going to be, is this a rational number or not? So if we convert this into a fraction, you will get 2 over 3, actually. Yeah. So because we know that 2 over 3, the denominator and the numerator, both of them are integers, so we can say this is a rational number. So as you can see, guys, if you see a decimal number, if it is like repeatable, like this one here, so actually sometimes we write this down as 0.6 and we have like the top like this, which means that this 6 is going to be repeated over and over and over again to infinity. So another example, let's say I have like 0.132, and so on and so on. So this is also a rational number, right? So why is it rational number? As you can see here, guys, it is repeatable. So 132. So this guy is repeated again and repeated again, and so on and so on. So if you see a decimal number in which it has a repetition, I mean, like it has a pattern of repeatable, right? Repeated, it's like it's the same thing like this one here, right? So this is also going to be a rational number. Okay, so if we go to the next type of number, which is irrational number, this guy does if we approximate the number into like decimals, it will not it doesn't have any pattern. Okay, so that's the difference between rational number and irrational number. Okay, let's just start learning about this irrational number. So again, irrational number isn't any number that is not rational. So what does it mean by that? It's an irrational number can only be approximated as a decimal value because it never repeats and it never terminates. So for example, like this one here. Okay, so for example, like square root of 2, square root of 3, cube root of 5, and then pi, and etc. So why are these numbers are irrational number? So I'm going to explain using a calculator. Okay, here is an example. So previously I said that square root of 2 is going to be an irrational number. So if you put this into the calculator like this, square root of 2, sorry, square root There you go. Okay, as you can see here, we have a lot of numbers. Right, I'm gonna make this into a little bigger. Well, we have 0.141423762337309880168872420097 and so on, so on, so on. So actually, it's not over in here. So we have a lot of digits, and it's going forever. Okay, if you see this number here, do you see any pattern like the previous example in integers? So if I go back to integer, sorry, rational number. So if I go to rational number again, guys, here, okay, like this guy over here, right, 0.666. Actually, this is repeatable, right? So this 6 repeated over and over and over again. So it has a pattern. And then another example like this one here, right? We have like pattern like 1 2 3 1 3 2 1 3 2 and so on, so on, so on, so on, right? So we have this pattern here. But when we see, and I said that irrational number like square root of 2, like this one here, this is one of the example of irrational number. If you put that into the calculator, you'll see this number here, right? So the question is, do you see any pattern in here? 4 1 4 2 1 3 5 6 2 3 7 3 0. There's no pattern, right? And it's going infinity. Okay, so that's why square root of 2 is an irrational number. So if we go back again, another example of irrational number is like square root of 3. Okay, square root of 3. So if I put square root of 3, okay, 3 square root of 3, here we go. So there we go. We have 1.7320508755268887729352744634150559, so on, so on, so on. So again, it's the same thing like the previous one. Square root of 2 is this one here, this guy over here, this numbers, and we don't see any pattern like repeating pattern. But this and this one here, square root of 3, is also the same thing. It doesn't have a repeatable pattern, right? So another question, guys, how about square root of 4? What do you think square root of 4? Is it going to be irrational or not? Okay, although it's like it's the same thing. I mean, like the form is like a square root, right? So the question is, we have square root of 3 is an irrational number. Square root of 3 is square root of 2 is irrational number. Square root of 3 is irrational number. How about square root of 4? Okay, so in order to know what is it going to be irrational or not, we can like can we simplify this? That's the question. If you're having difficulties in determining what is a square root of a number, you can just use the calculator. Okay, so if we put this into the calculator, square root of 4. Okay, I'm gonna have 4, and then I'll have square root, and here we go. So actually, it's just 2, right? So because this number here, square root of 4, can be simplified as another number, which is a simple number, which is 2, right? And 2, actually, if we go back to rational number, it is the same thing like 3, right? So 3 can be written as 3 over 1, so 2 actually can be written as 2 over 1. Okay, so again, if you see like a square root or something, and you want to determine whether the number, those roots or square roots are irrational or not, you have to use, for this time, you need to use the calculator. And then if you see any pattern, like repeatable pattern, it means that it is not an irrational number. Okay, let's continue. We have square root of 3. We have an example. The example is a cube root of 5. Okay, so if I have the calculator in Google here, I said cube root means that the root is not a square root, and this is like a cube root. Where do I get this cube? Cube means to the power of 3. So if we go back to the presentation here, guys, this is like we have this number on top here. Okay, I'm gonna use other color here. So this guy over here, right? So that is what we call the cube, right? So because this is like a root and we have a power of 3, so we call it cube root. So if I go back to the calculator here, so in here, guys, actually we have a lot of numbers here, right? But as you can see that it has 1.70997594668. It doesn't have any pattern. Again, it doesn't have any pattern. So because this number, if we convert that into a decimal, it doesn't have any pattern. It means that this is going to be an irrational number. Okay, let's go to the next one. We have pi, and then we have e. Okay, so this is interesting because when you are learning pi in elementary school, you use this pi to calculate the circumference or the area of circle, right? So remember that we have a pi, and then when you're in elementary school, you usually use this pi as 22 over 7. Okay, so what do you think, guys? So does this mean that the pi actually is a rational number? Actually, no. Okay, so actually, guys, this number 22 over 7 is just an approximation. It's not the exact value of pi. So why did you use this in elementary school? Because it is to make it easier to calculate. So for example, let's say you have a circle with a radius of 7. So when you want to know the area, right? Because the area of a circle has a formula of pi r squared, right? So the pi, let's say you have the radius of 7, so the pi you can write it down as 22 over 7, and then times it with 7 and times 7. You can just like cancel these numbers, right? And you have 154, right? This is one. And again, this is actually not the exact value of pi, but you use this because it is very close to the value of pi. As we know that we can write 22 over 7 as like 3.14 also, right? So let's prove whether the pi and 22 over 7 is the same or not. So if we go to the calculator again, so if I go 22 divided by 7. Okay, here we go, guys. Okay, as you can see here, guys, because 22 over 7 is a rational number, and we know that 22 over 7 has integers for both of the numerator and denominator, we can say that it is a rational number. We can prove that by if we convert this into a decimal number. As you can see, we have 3.14. This is the number that you usually use when using the value of pi if the radius or the diameter is not the multiple of 7, right? So, but actually we have a lot of numbers after that, right? We have 3.142857, 142857. As you can see here, guys, so these number here, the 142857, is repeating again, right? 142857, and then 142857, 142857, right? So in here, these numbers are repeating again and again and again and again to infinity, right? I mean, like it's going forever, right? So that's why this is the value of 22 divided by 7. So another question: what about pi? Okay, so this is the value of pi. So we have 100,000 digits of pi. Okay, here we go, guys. We have 3.1, 3.14, 159265358979333. Okay, so if you see all of these numbers, right, guys? Oh my god, so many numbers here. So many numbers. And as you can see that this number, the value of pi itself, the real value of pi, is not repeatable, right? So we have 141,592, and if you go to the previous value of 22 over 7, this is like 142,857. 142,857. This is 141,596. So although we have 3.14, it's the same like this one, 3.14, but after that number is not the same. This is like 2,857, right? So this guy is 15926, and it goes on forever, and it doesn't have any pattern. Okay, so because the exact value of pi is like this, right? It doesn't have any pattern, so we can conclude that the value of pi itself is the number of pi is irrational. So again, this is just an approximation. Right? So this is actually also 3.14, but we have another digits on the back, and this guy is not the same. So that's why pi is an irrational number. Okay, let's go to the next one. The next one is real number. So actually, a real number are all the numbers that we have learned from point 1, from types number 1 until number 5, right? We have natural number, right? And then we have whole number, and then we have integers, and then we have rational, and we have irrational. So all of these numbers, if we combine them together, we call those number the real number, okay? And it is denoted by the letter R. Okay, I forgot to mention the notation of rational number is actually Q. Okay, so this is as if you see Q in the mathematical form, like Q is a rational number, and then integers normally you write down as I or Z. Okay, Z stands for the word Zahl. I don't know if I make the correct pronunciation. It's from German. And yeah, if you see I or Z, it means that it is an integers. Okay. Okay, so I'm going to question type number 6. We have here real number, and I'm going to write down for you guys the notation. So natural number comes with N. Whole number sometimes just like W. Integers it can be have I or Z. Rational number is Q, and we don't have any symbol or notation for irrational number. Okay, so real number is denoted by the letter R. Okay, so again, a real number is actually all numbers on the number line. Okay, as you can see that -2 is an integers, right? This one is integers, and this one is a rational number, right? And this guy is a whole number, and this one is a natural number, right? And this one is an irrational number. So if we combine the previous number from type of number, like from a natural number, we have natural denoted by the letter N, and then we have a whole number. Sometimes it's written as W, and then we have integers, and it can be written as I or Z, and we have a rational number. Is it? Yeah, rational number. It's rational number is Q, and then we have irrational number. It doesn't have any notation actually. I mean like denotation. And all of these numbers, if we combine them together, it will be a real number. Okay, so if we want to draw this into like a Venn diagram, the Venn diagram would be like this. Okay, so we start from the slowest one, which is the natural number, right? So and then the whole numbers, right? Because we know that whole numbers is actually natural number, all natural numbers, but you add it with 0. So like if you have 0, it means that it's a whole number. And integers, like you only need to add, after you add the natural number 1 to 3 with 0, becomes a whole number. If you add it again with negative numbers, like -1, -2, -3, -4, and so on and so on, it will becomes an integers. Okay, and then the next one is rational number, and it can be like a fraction, but the fraction needs to be the numerator and denominator needs to be an integer, so that we can call it a rational number. So okay, I will give you an example on how to determine whether a number is included to natural, whole, integer, rational, irrational, or real numbers. Okay, so I've mentioned before, guys, because all of the numbers that we have learned are what they call a real number. So it means that all of these numbers, right? All of these numbers are real number, right? Because we can just like take all of them, right? Because all of them real number, because you will have the result. And then let's start from natural number first. Okay, so it's -3. Okay, as we know that natural number starts from 1, 1, 2, 3, 4, 5, 6, 7. It doesn't have any negative number. Because of that, which means that this is not a natural number. Okay, so that's the first one. The second one, whole number. Whole number starts from 0, 0, 1, 2, 3, 4, 5, 6, and so on and so on. It doesn't have any negative number, right? So because of that, the -3 is not a whole number. Okay. Another type of number is integers. As we know that integers can have like 0, 1, 2, 3, and it can also have a negative number like -1, -2, -3, -4, and so on and so on, right? So because -3 is included into the integers, so this is an integers. I'm gonna use this one. Okay, so as we know that integers for every integer, whole number, and natural number or rational number, it means that -3 is also a rational number. Okay, so if I go back to natural number starts from 1, 2, 3, 4, 5, so on, right? So this guy is not included in here, so it's not natural number. Okay, so and then whole numbers start from 0, 0, 1, 2, 3, 4. -3 is not here, so it's not a whole number. And integers, right? I'm gonna write down z here. We can start from negative to infinity, and then we have like -4, -3, -2, -1, 0, 1, 2, and so on, so on, to infinity. And because here we have this -3, right? That's why -3 is included into integers. Okay, and then rational number, which is q. And this guy here, it can be actually all numbers, like negative numbers, positive numbers, 0, but it can also be a if the number can be written as a fraction, right? We can say that it is a rational number. So actually we can write down -3 as -3/1, right? This guy is the numerator and this guy is the denominator, and because both of them are integers, so it means that this is also a rational number. Okay, so keep in mind that if it is a rational number, then it is not an irrational number. So be very careful. If this is a rational number, then it is not an irrational number. And so vice versa. If it is an irrational number, then it means that the number is not a rational number. Okay. Okay. So let's go back to the next one. That's why I need you to have the calculator with you guys. So we have this cube root of -8. So in order to know whether this is a natural whole or not, you need to simplify this using the calculator. Okay, I would like you to put this into the calculator, and or you can use if you don't have it yet, you can just like Google it, like write down cube root of -8. Cube root of -8 is -2, so we can simplify that if we go back to the question again. Here we go. Okay, so because we can simplify this as -2, we can write this down. Oh, this is -2. I can write that as -2, and then you can do the same thing like you did before in here, right? Okay, let's see another example here. This one, 1.27, right? 1.27 is actually 1.27, and then we have like a line on the top of 2 and 7, right? So actually, if I write this down in a complete form, we have 1.27, 27, 27, 27, and so on, so on, so on. Like it's recurring over and over and over. It's repeating again and again and again, like forever. Okay, 1.27, 1.27. As I previously mentioned, if we go back to the previous slides, yeah, about rational number. So this is going to be a rational number because it can actually be written as a fraction. Okay, but I'm not going to teach you now. I'm going to teach you another time about how to convert this into a fraction. Okay, so in here, because again it's repeatable again and again, so this is going to be a rational number because it can be it is repeatable and a real number. So because this is a rational number, it means that this is not going to be an irrational number. Right? Okay, the next step is we want to know whether this 1.27, 27, 27, and so on is a natural number, whole number, and integers. Okay, as you can see the pattern here, guys, so the natural number, whole number, and integers, all of them doesn't include any decimal number. Let's say like 1.25, 1.05, 0.5, and so on. These numbers are not included into the natural number, whole number, and also integers. So which means that this number doesn't include in this tree. Okay, so and then I've previously said before, so guys, I should have like tick all of these numbers because all of these numbers are actually real number. I mean like the numbers and the numbers in the number line. Yeah. Okay, so that's it. Okay, one more example for you guys. I have let's say this guy over here. Okay, 5 squared of 2 plus 4. Okay, again you can use the calculator. So if I change this into decimal number, right? If you put this into decimal number, you have like 11.07106781 and so on, so on, so on. And you can see that this guy doesn't have any pattern, right? It doesn't have any patterns. Like this one have flat pattern 27, 27, 27, 27. It's repeated over and over and over again. But this one is not. Okay, 0710 6781, so on, so on. It doesn't have any patterns, right? So which means that it doesn't have any pattern like this one in decimal place. So this is included into an irrational number. Okay, so if this guy is an irrational number, means that it is not going to be rational, integers, whole number, and natural number. Okay, so this is the pattern that you need to understand. Okay, so I would like you to like try all of these numbers and then put in the calculator, whether you can see whether it is repeatable or not, or it can it be simplified as another number in which it's like, oh, this one is like integers, or this one is although maybe you can see that there is like a square root and then like a fraction like this guy over here, right? Oh, what is that? Okay, so you don't really know, you don't really need to calculate it that manually. Just use the calculator so that you know that can it be simplified or not. Okay, so actually that is the explanation for this topic. Please do the exercise on Edmodo. I will be seeing you again next time. Thank you.